welcome to True Projects. In this video, we are going to explain about a project titled Construction Site Analysis using Test Mining and Natural Language Processing Technique. The research project presents the use of test mining and natural language processing techniques to analyze and construction site accidents. By employing the machine learning algorithm and TF-IDF, the past accident data is processed and converted into numeric vectors. The primary goal is to identify the underlying causes of accident and extract the information about dangerous objects or factors. Through these methods, the project aims to improve the worker safety by providing the insights and predictive analysis to prevent the accident in the new work scenarios. And the purpose of this research is to improve the safety of the workers at the construction site by examining the historical accident data using the test mining and natural language processing methods. The goal is to create machine learning algorithm that can effectively recognize the reasons behind accidents and identify the hazardous objects. By utilizing these findings, the aim is to proactively avoid future accidents and offer the suggestions for implementing the safety measure at construction site. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to build this project. First one is upload OSHA dataset. In this module, the dataset is uploaded and used for analysis. In the second module is run SVM algorithm. In this module, the support vector machine algorithm is implemented by using the classification and regression task. In the third module is run KNN algorithm. In this module, the KNN algorithm is implemented by using the non-parametric forms for both classification and regression tasks. In the fourth module is run Naive-Bayes algorithm. In this module, the Naive-Bayes algorithm is used as a probabilistic algorithm that applies Bayes' theorem with the assumption of independence between the features. And the fifth module is run decision tree algorithm. This module involves running the decision tree algorithm, which are hierarchical models make the decisions based on the features or attributes. In the sixth module is run logistic regression algorithm. In this module, the logistic regression algorithm is employed, which is a statistical method used for the binary classification problem. And the seventh module is run ensemble algorithm. Using this module, the run ensemble algorithm model is generated, where it combines the multiple individual classifiers to improve the prediction accuracy. And the eighth module is run optimized ensemble algorithm. Using this module, it involves running on optimized version of ensemble algorithm, taking the performance of sequential quadratic programming, which is a mathematical optimization algorithm. And the ninth module is precision graph. And this module involves generating the graph to evaluate the performance of all algorithms and causes of accidents by using the precision. And the 10th module is recall graph. And this module, it involves generating a graph that evaluates the performance of all algorithms by using the recall. And the 11th module is of F-score graph. Here, this module involves generating the graph to evaluate the performance of the algorithm by using the F-score metric. And the 12th module is accuracy graph. This module involves generating the graph to evaluate the performance of the algorithms and the causes of accidents by using the accuracy metric. And the 13th module is cause accident graph. In this module, the graph is generated to find the performance of the accident causes. And the fourth module is of predict accident module. In this module, the trained machine learning algorithm are used to predict the future accident based on the descriptions and the scenarios that are discussed. And the final module is chunker dangerous object extraction. This module focuses on extracting the dangerous objects or factors from the accident description. A rule-based chunker is developed utilizing the natural language processing technique such as parts of speech tagging. By analyzing the parts of speech tags and extracting the noun phrase, dangerous objects or factors contributing to the accidents can be identified. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of dataset and the test dataset, and the model folder consisting of PKL files which contains the algorithm information, and the site accident test and test1 or the Python main code files, and the run is a bat file. Instead of executing the program in a command line interface, we created a Windows bat file. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload OSHA Dataset button. By this, we are importing the dataset into the application by selecting and clicking on Open button. Here, we can see the dataset is loaded and total records found in the dataset is of 599 and the total features or words found in the dataset is of 13934. And click on Run SVM Algorithm button. By this, the SVM model is generated on the OSHA dataset. With giving an accuracy, precision, recall and F measure of 70%. And click on Run Neobase Algorithm, Run KNN Algorithm button. By this, the KNN model is generated on the pre-processed OSHA dataset with giving an accuracy, precision, recall and F measure of 55%. And click on Run Neobase Algorithm button. Here, the Neobase model is generated on the dataset with an accuracy, precision, recall, F measure of 50.8%. And click on Run Decision Tree Algorithm button. By this, the decision tree is generated with an accuracy, precision, recall, F measure of 60%. And click on Run Logistic Regression Algorithm button. By this, the logistic regression model is generated by using the OSHA dataset with giving an accuracy, F measure, recall and precision of 70%. And click on Run Ensemble Algorithm button. By this, the ensemble algorithm generated with the using of OSHA dataset with giving an precision, recall, F measure, accuracy of 68.3%. And click on Run Optimized Ensemble Algorithm model. By this, the optimized ensemble model is generated on the OSHA dataset with giving an accuracy, precision, recall, F measure of 87.5%. And click on Precision Graph button. Here, this is the precision graph where x-axis represents the algorithms we used and the y-axis represents the value of each precision for each algorithm. And click on Recall Graph button. By this, the graph is displayed where x-axis represents the algorithm names we used in this project and the y-axis represents the value of recall for each algorithm. And close this graph. And click on F-score graph button. By this, x-axis represents the algorithms we used and the y-axis represents of the value assigned for each algorithm of F-score. And close this graph. And click on Accuracy Graph button. Here x-axis represents of the algorithms we used and the y-axis represents of the accuracy of each technique which algorithm we used in this project. And close this graph. Click on Causes Accident Graph button. Here we get an pie graph where the orange part shows the struck by and red part shows caught in or between, and this part shows fall from elevation, and this part shows of others, and this part shows struck against, and this part shows the shock, and this spot shows of rubbed or abraded, and this way we can see the different cases of accidents of the construction site workers. And close this graph and click on predict accident button. By this we are redirected to the test dataset folder and select the test data from this and click on open button. By this we can predict the accident cause in or between by predicted accident cause is of other, predicted accident cause is of caught or in between, and this predicted cause is of shock. This is the test record and this is the result of that. And click on Shankar Dangerous Object Extraction button. These are the dangerous objects extracted from this. In this way, we can analyze the accidents on the construction site by using these various natural language processing algorithms. In conclusion, this study successfully demonstrates the effectiveness of the test mining and natural language processing technique for construction site accident analysis. By using the machine learning techniques and the cause of accidents were accurately identified, enabling the prevention of future incidents. The rule-based Shankar provide available in extracting the dangerous objects. The proposed ensemble algorithm with SQP optimization provides a robust classification approach. The research contributes to improving worker safety by leveraging the data-driven insights to mitigate the potential hazards at construction sites.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.